Hello, Algebra 2 class. We're going to continue with our study of our trig functions. We're going to expand our definition of sine, cosine, and tangent to a little more general form. So we're going to keep the old ideas. They're not going away. The idea of our opposite leg, our adjacent leg, and our hypotenuse of our triangles that we use to write ratios for our sine, cosine, and tangent. But we're now going to expand these definitions so that we can look at angles on a coordinate plane and find the trig functions for particular angles that show up on those coordinate planes. So I have labeled a coordinate plane with an angle, so for any angle theta, and that angle can be in any of the quadrants, first, second, third, or fourth quadrant. The example picture here is showing an angle in the second quadrant, but again, that angle can be anywhere between 0 and 360 degrees, so that this part of the angle here, the terminal side, can land anywhere on the coordinate plane. Of course, the initial ray on the angle will always be the positive side of the x-axis. Now, for any point on this particular terminal side of the angle, which would have an x-coordinate and a y-coordinate, we can then draw a triangle from that point down to the x-axis and create a right triangle. And when we create that right triangle, we're going to notice the legs will have to be the x and y coordinates. To get to this xy, you have to go x, in this case to the left, up y. And so once we have that triangle drawn, we can also notice that we'll have a hypotenuse, which would be the radius of the circle that we could form that would actually touch this point if we were to draw a circle all the way around. That's why this is called r, the radius. And then we can label these sides of the triangle further. We're going to notice for this angle theta, which will match whatever this angle is here, we're going to notice that this angle theta is going to be right next to x, so that will be our adjacent side. That angle theta will be opposite of the leg that is labeled y, and so we will label this side y, or opposite, and then our hypotenuse would be the radius. So we're going to want to make sure that we remember the opposite and adjacent leg idea and the hypotenuse of our triangle when we are defining our trig functions. So for the sine of theta, we can now say, instead of saying opposite over hypotenuse, which is still true, for this situation we can say it would be the opposite side, which is y, over the radius, r. Cosine then, instead of saying adjacent over hypotenuse, which it still is, the adjacent side is x, and the hypotenuse is r, so x over r. And our tangent function would be the opposite over adjacent side, which in this case is y over x. Now sometimes it's a little easier to see this if you pull this triangle out, and here I have pulled it out. There's my theta angle, and there's my right angle. So I've labeled everything that you see here. It's just a little bit larger and taken out, so there's no other distractions. Okay, so we would get the same situation here. Our sine would be y over r, opposite over hypotenuse, cosine x over r, adjacent over hypotenuse, and our tangent would be opposite over adjacent, y over x. So these definitions still hold. They mean exactly the same thing. All right, let's go ahead and put this into action and see how this works. Example 1, we're asked to evaluate sine, cosine, and tangent for the given angle. Your book is going to ask you for all 6 trigonometric functions, but remember, we are only going to be working with the first 3, sine, cosine, and tangent. So they've given you this angle theta here, and the point of interest is negative 4, 3. So if we go 4 to the left and up 3, we'll be at this point. And so I've labeled this length here, negative 4. So notice there is a negative sign up because the x-coordinate is negative 4. And the y-coordinate is 3, so we go 4 to the left up 3 to get to this point. So we can label this triangle here, negative 4, 3, and our hypotenuse would be r. I've pulled this triangle out to make it easier to figure out what we're doing here. So here's my x, which is negative 4, which is the adjacent side of the triangle with theta as the angle right here. And then our opposite side is y, which is 3, and our hypotenuse side r, which is 5. How did I figure out that's 5? Well, I used the Pythagorean theorem, of course. So the legs squared and added, 3 squared plus negative 4 squared is r squared. And then I just work it through to find out that r is 5. Nice classic 3, 4, 5 triangle here. Now I'm ready to write the sine, cosine, and tangent function evaluations because I now know my x, my y, and my r. Sine of theta, opposite over hypotenuse, which in this case, of course, will be y over r. Our y value is 3. our r value is 5. This radius will always be a positive value. The x and y can be both positive and negative, but our radius, will always be a positive value. Cosine of theta will be x over r. X is negative 4 in this case, and our radius is 5, so negative 4 over 5. Tangent of theta is y over x. That's going to be 3 over negative 4, 3 over negative 4. These fractions were already fully reduced, so there was nothing further to do once we wrote the fractions. If you can reduce the fraction, you must reduce it. If it's not already in simplest radical form, you must rewrite it in simplest radical form to be finished. So we'll practice that idea of getting our fractions into simplest radical form in guided practice 1. Again, we're evaluating sine, cosine, and tangent, and we're given this ordered pair 3, negative 3, so we will go to the right 3, that's our x value, go down 3, that's our y value, negative 3. And if we pulled out, we can also label our adjacent, opposite, and hypotenuse sides of our triangle because we're used to thinking about sine, cosine, and tangent with those labels. Our adjacent side will always match to our x in this particular case, and our y will match to our opposite, and our r will always be our hypotenuse. So when we are evaluating our trig functions, when we're on a coordinate plane, the x will always be the adjacent side of the triangle, y will always be the opposite, and r will always be the hypotenuse. All right, so we're not given the fact that this is 3 root 2 to start with. We'll just have an r here. We have to figure it out using the Pythagorean theorem. 3 squared plus negative 3 squared, that's what I'm doing here to figure out my r. I work at 3 on r squared is 18. And so r is the square root of 18, but that's not simplest radical form. Simplest radical form is rewrite it by pulling all the perfect squares out. So we rewrite it as 9 times 2, radical 9 times 2, and square root of 9 comes out as 3, 2 stays inside. So our hypotenuse is 3 root 2. Okay, now we're ready to write our sine, cosine, and tangent. So sine of theta is opposite over hypotenuse, y over r in this case, because opposite is always y and hypotenuse is always r. So that gives us negative 3, since our y is negative 3 over the hypotenuse, 3 root 2. And we're not done. Okay, this is a lovely, lovely fraction, but it's not simplest radical form. First, divide by 3 over 3, and that gives us negative 1 over root 2. Then to remove the radical from the denominator, multiply by root 2 over 2, and your final answer will be negative root 2 over 2. And notice these 2's do not cancel. You cannot cancel numbers that are inside and outside of a radical. So negative root 2 over 2 is our sine of theta. Cosine of theta is going to work similarly. We're going to put in 3 for our x and 3 root 2 for our r. Divide by 3 over 3, and you'll have 1 over root 2. Multiply by root 2 over root 2, and you'll have root 2 over 2 for your final answer. So the cosine of theta is almost the same as sine of theta, except it's a positive value, not a negative value. And that's because our x value is positive, and our y value is negative. That accounts for the difference in the signs here. Tangent of theta will be y over x. That's negative 3 over 3. So notice that we have negative 3 for y, x is 3, and that reduces down to negative 1. All right. So if you have radicals, that's how you're going to handle it in these situations, simplest radical form. Guided practice 2, evaluate sine, cosine, and tangent. And so in this case, we will avoid radicals. Yay, this is a perfect square situation. So we won't have the complications we had in guided practice 1 when we're writing our actual fractions. We're given negative 8 and 15 as our x and y values because there's our x coordinate negative 8. There's our positive y coordinate. And so if we take this triangle out again just to make it easier to look at, negative 8 is our x, which is our adjacent side to this angle theta, and 15 is our opposite side, which is y, and our hypotenuse we work out as 17 by using the Pythagorean theorem. Negative 8 squared plus 15 squared is r squared. This is a perfect square situation. The square root of 289 is 17. So no radicals for this particular problem. Now we take all this information, our y value, our x value, and our r value, and plug them into the definitions for sine, cosine, and tangent. Sine is y, that's the opposite, over r, that's the hypotenuse, so 15 over 17, done. That's as simplified as you can make it. Cosine is x over r, which is adjacent over the hypotenuse, that's negative 8 over 17. Again, that's fully reduced in simplest radical form. Tangent is y over x, that's opposite over adjacent, that's 15 over negative 8. And again, simplest radical form, we're done. There's no further simplifying to do. Last guided practice problem, same idea. So this whole lesson deals just with getting our evaluations of our sine, cosine, and tangent for angles that are presented to us on a coordinate plane. So we are given the ordered pair -5, -12. So there is our theta angle. And so we're going to take this triangle and bring it out just to make it easier to look at. So we have to figure out again what our radius is here using our Pythagorean theorem, which you can see here. We're going to find out, again, it's a perfect square situation. Radius is 13. So we're going to mark all this in next to this theta angle. That's this angle here. We have the adjacent side labeled x. The side that is far away, the leg that is far away from that angle theta, is the opposite side, which is labeled -12. And we figured out our hypotenuse, which is always a positive value, is 13. Now we're ready to write sine, cosine, and tangent values. So sine is opposite over hypotenuse, and in this case our opposite is y over our hypotenuse is r, -12 over 13, and that's fully reduced and in simplest radical form. Cosine of theta is going to be adjacent over hypotenuse, and that's going to, of course, be our x over our r, and that will give us -5 over 13, again already fully reduced. And tangent of theta is going to be our opposite over our adjacent, which is y over x, so that's -12 over -5. That does need to be simplified to 12 over 5. Negative divided by negative is a positive. And so we have all of our trig functions in simplest radical form here, so that completes this problem, as well as the guided practice for this lesson. I really encourage you to draw these triangles out separately from what you see on a coordinate plane. It'll be so much easier for you to be able to determine what your values are for your x, your y, and your r. All right, we'll see you next time.